Okay. This is another question on the sampling distribution. It says that it talks about delays for schedules of flights. So the delays to scheduled airline departures at an international airport are known to follow a skewed distribution. So from the beginning, they're telling you you don't have a normal distribution, but immediately you look here and you see that your sample size, this is n, equal 40, which is more than or equal to 30. Once the number is bigger than or equal to 30, you are fine, because you can use the z-score and you will get a normal distribution in this case. So you have a mean of 11 minutes, this is the delay, and standard deviation of 7 minutes. So let's write this here. And what is the probability that the mean delay of a random sample of 40 flights is, and we have A, B, and C. So I need to write things down. So first, our mean is 11 minutes. Standard deviation, sigma, is 7 minutes. My sample size is 40. And so I want to solve 3 questions. The first one here, it asks you what's the probability that, look at what it is, the mean delay, this is x bar, of course. X bar is more than 12 minutes. And this one, of course, it's asking you what is the probability that the mean delay of the flights is more than 12 minutes for 40 flights. And this one, what's the probability that x bar is less than 8 minutes? And the last one is asking you what's the probability that the mean delay x bar is between 9 and 10.5. So let's solve them one by one on the next 3 pages. So more than 12 minutes, so this is the same, we want the probability that x bar is more than 12. And so if you remember, this is a skewed distribution, so if we change it to the z-score, we need to do x bar minus mu over sigma divided by the square root of n. This we need to be bigger than 12, and then the mean, if you remember, it was 11, mu was 11 for this question, divided by the standard deviation was 7, and the sample size is, radical sample size was 40. And so this is the probability that this first one here is the z-score for this distribution. So this will be the probability that z is bigger than, and if you compute this number on your calculator, you should get exactly 0.90. And so you want the probability that the z-score is more than 0.90, or the area to the right. But we know that we can change this so that we can use the z table as 1 minus the probability of z less than 0.90. Watch the previous parts, then you will understand this. By now you should be a master of computing probabilities using the z table. So now this will be 1 minus, and let us find this probability that z is less than 0.90. So we need to find the z-score 0.90. So 0.90 is here, 0.9, and this is 0, so we have it here. So I'll make it bigger, it's 0.8159. Of course, what is this? This is the probability that z is less than 0.9. So the answer is 0.8159. So I'll put it here. So 0.8159. And if you subtract this from 1, you should get 0.1841. Okay? And if you write it as a percentage, of course, this is 18.41%. Okay? So this is the answer to the probability that the mean delay is more than 12 minutes. Now the next one is, what is the probability that the mean delay x bar is less than 8 minutes? It's the same exact question, and even easier because it has less than. So you change to the z-score x bar minus mu over sigma divided by root n is less than, and you do the same for the 8. So 8 minus, the mean was 11, the standard deviation was 7, and root of 40 is the sample size. And so this will be the probability that the z-score is less than, and if you compute this on your calculator, you should get exactly negative 2.71. You have to always approximate a z-score to 2 digits after the decimal. And now you can use the z table because it's less than. So let's go to the z table and find negative 2.71. So negative 2.7 is here, and 0.01 is here. So we go like this, and we will get this number. So the probability that the z-score is less than negative 2.7 is equal to, the number that we're after is 0.0034. So this will be the number that we will put back in the question here. So this is 0.0034. And if you want to write it, of course, as a percentage, this is a very small percentage. It's 0.34%. So it's less than half a percentage. Okay, very unlikely to happen that the mean delay in the flight is less than 8 minutes, because we know that the mean of the total flights is 11 minutes. So to be less than 8 minutes is almost unlikely even for a big group of flights, like 40 flights. Now, the last one is, again, the same type of question, just you need that the mean delay, this x bar, you want it to be between 9 and 10.5 minutes. So you do the same thing. Instead of x, you put x bar, you put x bar minus mu over sigma divided by root n, and you do the same for the two numbers. So the first number is 9 minus 11, the mean, over the standard deviation 7 over radical 40. And the other one is 10.5 minus 11 over 7 divided by radical 40. And if you do this on your calculator, you will get, first, of course, the z-score is in the middle, and the number to the left, you will get, after you approximate to 2 digits, minus 1.81, and the second number will be negative 0.45. Okay, and we know in order to compute the probability of a z-score between two values, this is the probability of the z-score less than the bigger value, in this case it's negative 0.45, minus the probability of the z-score less than the smaller value, minus 1.81. And so now let's go to the z table and find this number, negative 0.45. Negative 0.4 is here, and 0.05 is here. So I just move until I reach it, which is this number here. Yes. So the probability that z is less than negative 0.45, I can see it clearly, it's 0.3264. 0.3264. So this is 0.3264 minus, now the second one is the probability that z is less than negative 1.81. Let's find it. Negative 1.8 is here, and 0.01 is here. So I come down until I reach this number here. So I can write it, the probability that z is less than negative 1.81 is equal to 0.0351. So I go back and I put this number where it belongs. So this will be 0.0351. And if you compute this on your calculator, you will get 0.2913. And this would be the answer to the question, but you can write it as a percentage as 29.13%. So almost 30% is what? Is the probability that the mean delay of the 40 flights together would be bigger than 9 minutes, but less than 10.5 minutes. There is a 30% chance of this. And I will stop here.